There we go. Okay, so today, let's see, November 4th, right? Okay, logarithms are exponents. Logarithms are exponents. They don't look like exponents, blah, 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 logs mean logs, but they're exponents. In fact, right here, what do you see? Log base b of a equals what? E. And e is our exponent. So logarithms are our exponents, okay? So if our exponents, it's got to follow exponent rules. So don't write this down, just watch. Okay, don't write this down, just watch. But you have, let's go, x to the third times x to the fourth. What's the answer?
X to the seventh.
Right, so when you multiply bases, you add their exponents. Okay, logarithm rules. When we multiply bases, we're going to add the exponents. So I'll give you a rule here in a second, okay? Well, we have x to the seventh divided by x to the second. What's the answer?
X to the fifth.
Because when you divide bases, you subtract exponents. So we're going to have the same rules, okay? If you have x to the fourth to the fifth, what's the answer?
X to the, math, 9.
Close. 4 times 5? 20. It's okay, Lauren. You deserve one every now and then, right? Because you are just stellar. Okay, so when you multiply exponents, you take an exponent to an exponent, you multiply. So when you take you ready? When you take an exponent, that's the next one. Look at this. It's weird, but that's the next one. Right? Remember we said logarithms? You take an exponent to an exponent, you'll multiply. So let me give you the rules of what these are. And all three of these rules are following the rules we already know from Algebra 1. Okay? So if I take a look at my first rule called my product rule, if we are going to multiply bases, base n and m are bases, okay? Then we are going to add our exponents. So we can go log of n plus log of m. Now the base is invisible. I didn't put the base in. You could put the base in, but if there's no base, what's the invisible base? 10, right? So it's base 10. It could be any base. It could be any base, okay? The bases have to be the same. It has to be the same because you can't do x's and y's. Does that make sense? Bases always have to be the same. If I divide bases, I subtract their exponents. So log n subtract log m. Same base rule, just seems really obvious. Log of base b of m, log of base b of n, then we can just basically say n has to be equal to m. I mean, that just, hopefully that makes sense. Because to make them equal,
You just cancel out the 1b.
you can, or just know that to make them equal, these two have to be equal because everything else is,
Yep.
right? I mean, that just makes sense. But it has to be the same base. It has to be the same base. And I want to reiterate the same base. Okay, so in your first example, you had x to the third times y to the fourth. Okay, you can't do this because the bases are different. With logarithms, if you have a base 2 and a base 3, you can't do it. Does that make sense? Same bases, otherwise you cannot do it. Right? I know, you guys have the best seat in the house, but it's hard to pay attention when you got the best seat in the house, isn't it? Now, the power rule. This is an exponent. That is an exponent. So if you have a base, an exponent to an exponent, you multiply. So you're going to go p times the log of m. And I'm going to circle this one because it's the one we use the most when we do our problems. So that's the one we're going to use the most in, okay? So taking our rules. When we do today's lesson, it's just going to seem like there's no purpose, okay? We're just manipulating. But if you take calculus, and I assume some of you will, It's a really handy thing to do in calculus because it will help you solve problems much more easily in calculus if you know the log rules, okay? So, good thing I taught calculus for about 20 years, huh? I know it. So, example 1. We're going to take what we have here and we're going to expand it. The first thing I want to do is use this rule up here. I'm going to use the product rule first. So I see a times. So I'm going to rewrite it as a log of something plus a log of something, okay? So I'm going to use the first rule, my product rule. All right, log base 3 of a plus log base 3 of b to the 4th. And I'll highlight what I just did. I used the product rule right here. Because of times, I separated them by plus. Okay. Now, the second rule I'm going to use is the power rule. I have an exponent to an exponent. So in the power rule, I brought the p down and I multiplied it. Just brought the p down. So we're just going to bring the 4 down. Yeah.
Base 3b.
Got it. So my answer is going to be log base 3 of a plus a 4. The 4 comes down. Log base 3 of b. Okay. Now, it really doesn't mean anything to you right now at all. However, later on it will, and especially if you take calculus, it's really going to be handy. Okay.
So you can like let you solve the things more easily.
Yeah, that's exactly it. So in calculus, and we don't know calculus yet, but when you get to calculus, you're going to have a product rule, which is going to take the chain rule. You're going to have a power rule, which is going to take the chain rule. And then you got to do all of that in one problem, or you just make it into two easy problems so you get the answer. That's how it's going to help you in calculus, okay? Example 2. So before I do anything, let's rewrite this. I'm going to rewrite this as log base 5 of the square root. Now, so I'm going to make it to the 1/2 power, okay? X cubed divided by y to the 1/2 power. You okay with that? Square root 1/2 power?
Why is it to the 1/2 and not like squared?
Great question. So a square root, Vince, has two invisible numbers, okay? One invisible number is 2. We don't write it, do we? We'd write a cube root. We'd write a 4th root, but we don't write the square root because we have the implied 2 here, okay? And there's an exponent right here of 1. Again, we wouldn't write it because it's kind of like an invisible 1. So you get the 1/2 power from a square root. See the 1/2 from that? So there's a 2 right in here.
Oh, yeah.
Yep.
Oh, yeah.
So now the first thing I'm going to do is I'm going to use my power rule. So the first thing I'm going to do is use this rule up here first. I'll take the 1/2 and I'll bring it down. Okay, so if you've got an exponent, I'm just going to bring it down. So I'll rewrite it as a 1/2 times my log base 5 of x cubed over y. All right, how am I doing? So you got an exponent, always comes down. I used to say float the exponent down, get a logarithm, float the exponent down, okay? Now, I've got a divide by, so I'm going to change my divide by to a subtraction. I'm going to rewrite them both, but I'm going to separate them both by a subtraction. So I'm going to have my 1/2 log base 5 of x cubed subtract log base 5 of y. How am I doing? Okay, I will show you again 2 things I've done so you really see it. All right. First thing I did is I brought logarithm, exponent, brought that down first, okay? That first. So exponent, you got a log with an exponent, float it down, okay? Then, because of this divide by, I separate them by subtract, okay? Now I got one more thing to do. Do you see it?
The x to the 3rd.
Yeah, so then I'm going to float this x to the 3rd right there.
Yeah.
And then I'll have it. Okay, so let me erase this mess. Let's do that. All right. Let's see what that So then I'm going to float the 3 down right to there, and I'll have an answer of a 1/2 times a 3 log base 5 of x minus a log base 5 of y. And if you want to, you could bring the 1/2 in, if you want to. You don't have to, okay? All right, now, let's do the opposite. Let's do the opposite. So, let's work it backwards. It says to a single log. So in the end, I want to say log of, blah, 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 right? Just a log of. So the first thing I'm going to do is I see some exponents. Now, they don't look like exponents, but there's some exponents. Do you see any exponents? This 3 was an exponent. I'm going to bring it back in. This 1/2 was an exponent, so I'm going to bring it back in. It was an exponent, but I floated it down, right? Now I want to bring it back in as an exponent. All right, let me rewrite that with its exponent. So I'm going to write, okay, I'm going to rewrite it as log a cubed minus log b to the 1/2, okay? And I'm probably going to write that as a square root. You okay with that? I just write that as a square root. Vince, you with me on the square root? Mm-hmm. Good. Now, the last thing I'm going to do is, you see this subtract? I'm going to bring them together as a single log as with divide. So I'm going to rewrite this as a log of a to the 3rd divided by the square root of b. And there it is, as a single log. And it's an invisible base, so what's my invisible base? Good. Right. Example 4. Express y in terms of x. So I'm going to try and put these two expressions together first. Okay, I'm going to simplify this. So I'm just going to write, first of all, ln of y equals, let's see. I have an exponent that got floated down, so I'm going to put my exponent back in. Okay, that was an exponent. I'm going to bring it back in. So I have an ln of x to the 1/3 power plus ln 4, okay? Then, because it's plus, I'm going to bring them together as a single logarithm, okay? So I'll rewrite that as ln of, well, of a 4, I'll put the 4 in front, x to the 1/3 power. I just like the 4 in front. You guys do too, right? It looks stupid if the 4 is in the back. You okay with that? I mean, we don't write it, we wouldn't write it like this. It look dumb. X 1/3 4, right? It's like 2x, right? Or 3x. I wouldn't write it as x3. That would be dumb. You guys agree? Yeah, so we should put that in front. And then finally, it's ln, right? ln, and then we can just say y equals 4x to the 1/3, right? Because we want it in terms of y in terms of x. So, Kai, I got to borrow your phone from you, and I'll give it back at the end of the period. See, even Kai, you guys. All right, thanks, Kai. So then I'm going to have y equals just a 4x to the 1/3, and to be fancy, because I like to be fancy, 4 times the cube root of x. How's that, Vincent? You okay with the cube root?
Oh yeah, that's not fancy.
See, that's why you asked us such a good question, because you totally get it now, don't you?
Yeah.
Does that make sense? Thumbs up? I saw one thumb up. There you go, 2, 3, 4, 5, there you go, 6, 7, okay, good. Turn the page. All right, now, logarithm, now solve for logs. I want to solve for x. I have too many logs. I want to try and get this down and simplify it. So the first thing I'm going to do is bring these two logs together. See the plus right here? So I'm going to rewrite it, and I'm going to put these two logarithms together. So I'm going to rewrite this as log base 4 of, and I'm going to use brackets because it's just going to seem easier if I use a bracket, because I'm going to go in x minus 4 times an x. I use a bracket so you can see that I put put these two together. See that? That's why I like a bracket. Just less confusing, okay? Put these two together, okay? Plus means times, right? Now, they're both log base 4, right? Log base 4, what's inside must be equal, so I should have a x minus 4 times an x equals a 5. I can do that. I've got a x squared minus a 4x equals 5. Oh, looks like I might have to factor, right? Bring over the 5. X squared minus 4x minus 5 equals 0.
So you just cancel the two log base 4s?
Right, right, and that's one of our rules. In fact, it's that rule right there. Remember we did that rule right there? If you got log of something, what's inside must be equal, right? So then, factor x minus 5, x plus 1, everybody agree with that?
Yep.
Or x equals 5, and x equals negative 1. But not negative 1, not negative 1. How come? We learned this yesterday. Remember when I was given candy? Why not negative 1? Remember when I was given candy? Why not negative 1? Because you put negative 1 right there. You cannot do logs of negative numbers.
Oh, yeah.
Right? We learned that yesterday. So we throw out the negative 1 and we just have the 4, okay? All right, last one. One of my favorites. I like this one, okay? All right, we're going to do the first initial step the same because I see a plus sign. I'm going to bring it together. Log base 2 of x times x minus 2 equals 3. Now this one's different because you can't cancel the logs out because you have log of 2, log of 2. You can do this. You're smart enough. We can get rid of log. We're going to change it to exponential form. What did you do on your maze? What did you do on your maze? What did you do on your maze?
Change it to exponential form.
So what can I write?
You write 2 to the 3rd power.
2 to the 3rd power equals x times x minus 2. Ah, it's gone. Cool, huh? Nice job. 2 to the 3rd power is 8 x squared minus 2x, right? Bring over my 8. I'm going to have 0 equals x squared minus 2x minus 8, right? X minus 4, x plus 2. X equals 4 and x equals negative 2, but probably not negative 2, correct? Okay, there you go. Boom, throw that out. What do you think? Not bad? Thumbs up? Okay, so you've got a homework assignment and lots of time to get it done, right?